in a long ways, which is going to be Seattle Code Camp, which I think Slobo wanted to say a few things about.
Yeah, the Seattle Code Camp is, for all of you who don't know, it's a community conference, one-day conference. We have about 40, 50 talks on various technologies, and it's free. That's what we try to make it free. Every year, past 2 years has been free. In order to do that, we need people to help us out with that. One of the things we're looking for help at this moment is for our website. So right now it's on GitHub. If you go there, you can find it. And you need a link to that probably. So the best way to figure that out is either contact Chris or myself through Meetup. Just send us an email, message to Meetup, and I'll give you the link. And over there on GitHub, you will see we have issues that we want to fix. So you can just contact me, say I'm interested in working on this issue, and I'll help you out help you set up the machine. I've uploaded a PowerShell script, so if you download, it's ASP.NET 4 or 5. If you just run the PowerShell script, that will install the database, and you should be good to go. It should be pretty trivial. So if anybody's interested, let me know. I can talk to you later, and you can send me a message.
We're also looking for some help with some design type tasks.
Yeah, absolutely.
You know a designer or are a designer or something like that, that would be awesome. Kind of want to refresh the design this year. So.
And I have some stickers for netda. If anybody wants some stickers, if you're here for the first time, I'll give you a sticker. Anybody wants some stickers?
Anybody out looking for a gig right now? Looking for a job?
Looking for internet. What happened with Microsoft?
Yes. I think the problem is that I think it's MSFT open or MSFT open, and it's gone today. I don't know why it is. I'm sorry.
They were talking about switching it out.
Oh, are they?
To a new guest.
To a new guest?
Yeah.
It's not working for me, so I don't know. I'm sorry. Same as
Anybody
you.
else
but I
here for the
should
first
have
time?
Anybody looking for a gig? Looking for a job or looking to hire people?
Yeah, it's
back
actually
there.
listed as MSFT guest now. I don't know if it works.
Not a problem. Excellent. I'll say I'm always looking for speakers. Right now I think I'm booked out, if I remember right, through June. So I'll be booking for July next. We tend to put them up on the site about 3 months in advance, so we kind of keep them rolling out there and you'll get some notifications. But if you guys either have a topic or if you've seen someone speak on a particular .NET related topic that you think would be relevant for the group, please send me an email at chris@kinsman.net. I'll go ahead and follow up with them and see if I can't find someone to present on that topic. I've had a request at this point for some machine learning type stuff. I'm trying to find a speaker for that right now. If anyone knows someone on one of the teams or knows someone that's doing a lot of that, I'd be interested in getting a contact on that also. So from there, next month is going to be some stuff with Azure API management, talking about how you can manage change and churn in your APIs using the Azure API management tools on April 3rd. And that is it for me. And I'm going to turn it over to this gentleman here so he can tell us a little bit about DocumentDB.
Oh, did you not find that slide?
Oh, I put it in there and it must not have got in there. My bad. One more thing. When Lauren's here,
Yes.
go ahead.
Sure. All right, so the afterwards is back this month. How this works is after the meetup is over, about 8:30, a group of us meet over in the Commons, which is on the campus. It's just off of 40th Street. Park in the big parking garage, the big underground 4,000 space lot. Come out there. It's a bar/restaurant that's open on the campus, and a group of us, chat about whatever the meetup, other things, and it's always a great time. Every time I do it, it's worth it, so please come join us if you're interested. And if you don't know where it is, you want some help, come find me afterward. I'll tell you how to get there.
Can you hear me?
Yeah.
So good evening. My name is Shyam Nair. I run program management and product management for Azure DocumentDB. How many of you are familiar with DocumentDB? And with me is Govind. Govind is our program manager in the team. So I wasn't sure if a lot of folks were familiar with DocumentDB, what level I should actually go into. So I may have a mix of some high-level stuff, a little bit of screenshots in terms of some of the things that you can do with DocumentDB. Govind will demo some aspects of DocumentDB. But what I would like is if you think, I need to go one level higher or lower, I have other material that I can go through. So to make it informal, let me know, and then I will pivot. So I don't know how many, but just to kick off, anyone who knows why we ended up building yet another database? It wasn't like there isn't a whole lot of databases on this planet, but. So, let's start off with a story. It was a few years ago. DocumentDB was started by a gentleman by name Dharma Shukla. Dharma is a distinguished engineer at Microsoft. He's actually the general manager running all of our NoSQL services as well as our open source analytics services. And as Microsoft was moving more and more towards the cloud, cloud mobile first world, and we were getting all our software and services onto the cloud, there definitely was a need to actually have a globally distributed database to support all of it. So we saw the need within Microsoft itself, and then we also saw that customers would be having the same kind of challenge as they were moving up to the cloud, that they would need a really globally distributed database. If you look back at most of the databases, they were built for scale, but they were always built for scaling up. More and more beefy machines came in, or machines that were working together. They were distributed across machines, but they were not distributed across regions. It was not globally distributed. You always had global replication or some form of replication for business continuity and disaster recovery, but you weren't actually building a database in the context of, let's first think about global replication. DocumentDB was actually started by Dharma and a few other colleagues. This came out of some of the research that MSR had done, and started off as a small team outside of the core database engine group within Microsoft. Microsoft has a pretty healthy database business, in terms of revenue, so in the second, and in terms of growth, the fastest growing database business. We have a pretty healthy database business. So it was a small team that actually started DocumentDB. One of the things that the team thought about was, how do we really build such that as Azure, then small Azure expands across regions, it's about 36 regions now, how do we really enable customers to have one database that spans across all of these continents, spans across all of these geographies? So DocumentDB was born with that idea of really having global distribution from the ground up. The reason I emphasize on this is it's very different from thinking about global replication from a BCDR standpoint, because every database would actually have global replication. Some of them make it much easier to do it, but DocumentDB thinks about it from a ground up, it is globally distributed. DocumentDB is what we call as an Azure Ring 0 service. It's an internally used term. I just decided to just go with that. Basically what that means is, when we roll out a region, we make sure that there are a few services that are out there. You can guess some of them. Compute needs to be there, networking needs to be there, storage needs to be there, SQL database, and then DocumentDB. So these are Ring 0 services. Every region will have it. Why? A whole lot of the higher level Azure services, Azure has a ton of services if you're familiar with it. A whole lot of the higher services, as well as suites like IoT and many other suites, are actually built on top of these core services. So DocumentDB will be there in every region, every small or big that Azure goes into, whether it's sovereign clouds, whether it is government clouds, whether it is, we are already in all the sovereign clouds, and we will be, as the government clouds roll out, we are part of that too. The way DocumentDB actually implements geo distribution is by, it automatically supports multiple replications. So we have a quorum of replicas in one particular region. You have, their data is actually partitioned across in one particular region. And all you have to do is go to the portal or use the REST API or the SDK and actually say, look, I want it in these many number of regions. We globally replicate data across all of these regions. And any of these regions, you can actually read from it. And there's no latency. You can actually read from those regions. You can actually, there are customers who do this in terms of, they follow the Sun model with DocumentDB, one database account with collection sitting in the West US region and a collection sitting in Japan region, and based on where the Sun is and where the application is, they can actually fail over to that particular region to use a database there. So we are able to provide the low latency characteristics that mobile applications as well as these high scale applications need by enabling a multi-region replication. Using multi-homing APIs, I actually will show you what that actually means. You can set an array of regions, and you don't have to think about connecting to a particular region as such. It's a logical endpoint, and if a particular region goes down, and if it fails over to another region, your application will still continue to work because it's a logical endpoint, and the logical endpoint knows to go to the next region where the database is alive. So recently, we actually had not DocumentDB as such, we actually had a very large but a very small Azure outage a couple of weeks ago. And there were customers, of ours who, we were also impacted because of some of the Azure things. There were customers of ours who had actually set up multi-region account and had set up automatic failover that you didn't experience any availability issue. We were able to provide the same 99.99 availability that we actually guarantee because it automatically failed over to that particular region. To do something like follow the sun model, there is a way you can you can actually do this using manual failover. You can decide to say like this time of the day just fail over to this particular one, no data loss, and it continues, and you get the benefit of it. I'll talk about the SLA as I get along. If you look at this, I think Govind will do a demo a little later. So to set up a DocumentDB account and have it replicate across regions, all you have to do is in the portal, you actually select these regions, and immediately within the, there is a seeding time, but we guarantee that within 16 minutes, all the data will be seeded across to the other side. You actually have all of the other regions available for you for use. If you're familiar with the CAP theorem, I don't know, how many of you are familiar with CAP theorem as such? CAP theorem basically says if data is partitioned across a network, you can either get consistency or availability, right? There is the backlog stuff, there's a lot more theoretical aspects of it. So one thing I wanted to highlight is in terms of, folks also think about, geo-distributed database, but what is my real latency out there? DocumentDB actually guarantees that for the 99 percentile of your queries, and this is an SLA, financially backed SLA that we have, that 99% of your queries, reads will be under 10 milliseconds and writes will be under 15 milliseconds. We are still actively working on it so that this will be much lower. Now, a little bit of a sales pitch, when you talk to different database vendors, you often hear, no, I can give you 1 millisecond latency, I can give you 2 millisecond latency. That's true, you can, but is the data going to be consistent? Is the data going to be available? So all of these aspects need to be thought through when you think about a low latency application. So in our case, the fact that real world requires latencies of this level and we are able to give it is actually a big aspect of DocumentDB. How are we able to do this? Because we are globally distributed, we can actually serve reads and writes from the local region. If you're familiar with some of the write-optimized last-week database engine that actually some of our Microsoft database engine actually has, DocumentDB is actually built with a write-free optimized algorithm, batch-free, and it's built on SSDs. So it's commodity hardware that cloud users with fast SSDs. Talk about the indexing in the future. So when I talk about guaranteed low latency, if you look at this image, you can actually see this is read throughput and this is write throughput. So you can actually see it's about 1 million writes, close to 1 million writes per second, it's about 1 million reads per second. We are consistently able to keep it at a single account with 110K collections under 1 millisecond for reads and somewhere under 14-15 milliseconds for writes. So we have global distribution, we have low latency. Now the next thing is scale, right? With cloud, everybody wants elasticity in scale. And most often we talk about elasticity in the context of storage. You can scale storage, but there is another aspect that you need to scale. DocumentDB is a throughput-based system. So you define how much throughput you actually require, and you can scale that throughput limitlessly. In our case, the way the system works is, on the server side, all your data is actually transparently partitioned. So, which means if you set, you can actually start off with, we recently reduced the number of request units that you would require per second for a partition collection to 2,500. You can start off with 2,500 and go up to millions and millions of request units that you can actually provision. We guarantee you that particular request unit for that particular second will be given to you. And again, it's backed by financially guaranteed financial SLA. So it's not like, hey, look, it's hidden from the user. We have support for TTL. So if you want to optionally evict your old data, you can just set it using TTL, time to leave. Throughput scaling, right? One of the aspects of a cloud-based system is the ability to quickly scale throughput from, I talked about from, hundreds or thousands of request units to millions. How long does it take? We can instantaneously scale throughput. You can scale throughput in one particular region and it will actually go to all the regions which we have set up. So instantaneously being able to scale throughput enables you to again follow the sun model where if you really need 1 million request units in a particular region because the app is hot, or you have a Twitter client and say something happened in or San Jose, there was a flood, and suddenly you really need a lot more information, tweets about the San Jose flood. You really need a lot more throughput over there. You can do that, but maybe somewhere in Japan, I'm just using this as an example, you may not need that level of throughput because there isn't something trending over there. Twitter may not be the right example because there's a lot of topics that trend in Twitter, but there may be, think about a system that actually shows about weather information or something else. You could actually have these throughputs configured per region. We are actually working on something, and it's actually released in terms of enabling requests per minute, which is we guarantee you that for a particular second, whatever is your configured throughput, we provide it to you. But there are certain workloads that are actually much more spread out. They are actually much more normalized across the minute. So instead of paying for all that throughput for that particular second, you can actually pay it for just that. You can use the same number of throughput, but spread it across a whole minute. I actually have an example of, this is a real customer, and this customer actually used, this is an e-commerce customer. So this is the time period where this e-commerce customer was actually setting up a very high throughput because they were actually doing the testing before the big sale. And then, in preparation, they actually set it down. Somewhere a couple of days before Black Friday, they actually increased the throughput. And then, before Cyber Monday, they reduced the throughput, then again they increased the throughput. So you can see this particular customer, they didn't have to pay for this amount of throughput, the top line, the ceiling of the throughput all the time. They only had to use it for this particular time. And then we have the same customer actually reduce the throughput to a different level based on what their workload is.
So from the point in time you request a throughput change, how long is it?
It's instantaneous. We guarantee within 5 seconds. I think there is an SLA, it's instantaneous in all the regions.
Is there any limits on how many times you can scale down or scale up?
No, there is no limit in terms of how many times you can scale down or scale up, but the metering is at an hour granularity. So if you change multiple times within an hour, whatever is the maximum that you ask within the hour is what you'll be metered for. And with throughput guarantees, you imagine in this case, you have 3 regions and you are provisioning 2 million request units in a particular region. And what you get is if these are in 3 regions, you will get 6 million request units provisioned there. And it's guaranteed that for the reads and writes that you occur in these regions, it's available to you. So we talked about geo-distribution, we talked about latency, we talked about throughput guarantees, and I talked about CAP theorem. So this is an interesting aspect that we need to talk about, which is consistency. DocumentDB has well-defined consistency models. Everybody has to navigate CAP theorem. It's something real. So how do we really do that? Is we actually provide a consistency model that goes all the way from strong to eventual consistency, which means you can define based on your application workload what kind of consistency do you require. Do you want linear available guarantees with strong, or do you really want a consistent prefix kind of model where there's no holes in the system? Or you really are thinking, or let's think about a client, a mobile client that talks to the database, or a shopping cart application. When I'm actually working with a shopping cart application, what matters to me is what I'm adding to the shopping cart or removing from the shopping cart. I want to see that in sequential order. But I don't care what Govind is adding to the shopping cart. I shouldn't see it. But I don't care what is the order of that and how I see it. So I can actually define a session-based one as long as the application knows about how to control the session. So what we see in this is in most cases, real-world applications end up using somewhere the session or a little bit of the bounded stainless. The reason for bounded stainless is you can actually define that you can be lagging by a particular amount of time, or you can lag it by a particular number of events. And that comes into play especially when you actually have a globally distributed database. If it's not globally distributed, bound and stainless is pretty much the same as closer to strong. If you look, if you look at this in terms of just to understand how it actually matters, with the packet trade-offs, you need to think about consistency and latency, availability and latency, etc. So in the case of strong, as you see, the writes always take the same capacity. What I'm showing here is the amount of request units required to do a particular write. That's the same, but if you think about strong and bounded stainless versus session and eventual, the amount of capacity you really require for strong is twice the session. So which means you can actually get more, in this case, you can actually get more read done with the same number of, that's 4 request units than what you can actually get with bounded stainless or strong. Because we have a model where we actually write to a quorum of replicas before we actually return, and then you read from those quorum of replicas. And based on which consistency model you choose, we will decide the number of quorum of replicas you need to write to, as well as geo-distribute. So, talks about 4 things, recapping: geo-distribution, latency, consistency, and throughput guarantee. Now, it's easy to say all of this, right? The one thing that we have done, which is unique, I don't know Azure Service event, if there's somebody from Microsoft here, no Azure Service event does this, which is we actually have a comprehensive SLA that backs all of this. This SLA is currently in the factory, as in just pushing it out, we need to go through all the legal stuff, etc. We've been practicing this for the last 6 months, but we started pushing this out early Jan, and as of last Friday, which is the 1st of March, that's why it's March, it's actually approved and it's going up in there. So we actually have these 4 SLAs for all these 4 things that we talk about and at 4 nines. So availability guarantees, latency guarantees, consistency guarantees, and throughput guarantees at 4 nines. Now, yeah, I have an SLA, I talked about all of this. How do you, as a developer, verify that you actually get it? So all the metrics that I talk about are transparently available in our portal. You go to the portal for your workload, you can see, hey, look, this is the availability SLA that DocumentDB promises. This is the SLA you have actually been getting. This is an actual screenshot for a particular account. This is the read latency that DocumentDB promises. This is the read latency that you have been getting. This is the write latency. That's the provisioned RU versus what you have actually consumed, or consumed versus provision. You can see the consistency. So all of this is available in the portal. Now, actually, I'll ask Govind to give you a little bit of a tour of some of these features, and probably mostly focused on the geo-distribution as well. Make sure that this is live and all.
So what you're going to see now is, So what you're going to see is a globally distributed application. All these regions have the front end, and there is one DocumentDB database which is distributed across the world. So what you're seeing now is also the latency, the read latency. Okay? So notice everywhere it is basically about less than a millisecond or about a millisecond. I will come to why the central US is showing a particular latency. It is something, what we do is the read latency is either defined at the account level, or you can define at every read. So why would this matter, right? This is very important because all of these guys are actually reading data locally. And why would it, how does it make sense to you? So let us show you something else which will make a little bit more sense of all this. Okay? So I think this is very...
This is not shipping UI, by the way, just a demo.
Yeah, definitely not. I don't think we are very good. So let me see if I can get the latency. Yeah, I want to reduce it and I want to, because otherwise I cannot control it. It keeps going.
You may have Scale.
Yeah, control shift minus, let me try once more. Yeah, I don't think it will be visible to folks at the end, but I will try to explain what this chart means. This chart basically shows the round trip latency between various locations. So what you want to focus on is basically, there is a latency from Australia East or Australia Southeast for that matter, all the way to East US is pretty heavy. It's about 240 or 250 milliseconds, right? And there is one more thing that you want to notice, and this is a tip, right? If you deploy your application in US, deploy it to South Central US, you'll always get equidistant, basically latency from both locations, both the locations. So you can save some money for other kind of applications. So first thing is, there is
Just to add,
Yeah.
just latency you're talking about is the speed of light between these regions,
Yes.
nothing to do with DocumentDB.
Of course. This is, so thanks for clarifying. As usual, it's good to have a boss around when you're making explanations. Now the point is, how does it matter? Why does it matter? So what I will do is I will just switch over and add the right here, and then you will see a difference. And the difference is expected. What should you see? Let us say focus on Australia Southeast. What you should see is the latency that you see from Australia plus the right latency that we guarantee you, right? So this crossed. Oops, that's what. Okay. So there should be a green line coming in, yeah. So this is what you want to focus on. So you will see that there is 250, let's say Australia East. So it's about 250, you cannot really make out you don't have to screen. So it is about 240 plus 15 milliseconds maximum is what the latency that we provide. So that means all the writes are going all the way across from these locations to our write region, which is East US. Okay. Now the important point here is, how does it make, what has this got to do with what we have been doing all these years, right? I think there are a lot of subtle points which Shah mentioned. For the guys who have been using DocumentDB, doesn't matter, but for most of people from my generation, and I like to say my generation because I have spent time on configuring SQL servers, oracles, and other pieces. Where do we spend time on for a database? Performance, right? And why do we spend, in performance, what do we actually manage? Indexing, right? So one key thing which he mentioned, and I think it might have passed you by, is that all the data that is inserted is auto-indexed. Okay, that's a pretty impressive thing. So all these guarantees that we're giving are based on 2 MB of data coming in, getting auto-indexed, and we provide you all these guarantees, read and write. There is another important thing, where do you spend time today? On databases, forget, just imagine, even NoSQL databases, from the guys across the lake versus guys that you buy and pay money for. Availability, right? And as you see that we have basically taken away, availability is just a byproduct of us being there. What do I mean by that? What I mean by that is when you create a database, it has ability, or it is basically born with ability to distribute right from the beginning. Within a data center, across the data centers. Okay? And as we do that, all the consistency requirements and everything comes into picture. So our job is to basically make the lives of people who develop software easy, so that we get some time away from the work and go back and look at the families that we have been working for. Right? But this part is looks very good and all that, but let me try one more thing. Again, as long as, let's see, so now let's look at this particular account. This particular account, if I see the matrix as Shyam was mentioning earlier, so it should be running for quite some time. Let's pick up. Okay, so you see about, so it is just 6:30 p.m. onwards, so 2 million odd requests per 5 minutes is what you're seeing. So this is a running system. This is something which is not that we have created out of this thing is a running system. And you can see other latencies also. So these are the latencies that you see. Okay? And this is the throughput that we have got. This is running at a session consistency. I will not get into every piece of detail here, but what I wanted to show you here is this piece, right? So the way to add a region is basically pick up a region. In this case, if I had to add another region, I would just click on it and just go ahead and choose it, right? Central US or something like that. We have added UK South too, so you could add that. We are not adding this. These are 2 Korea regions which went live last month at this point of time. Now let us do one interesting thing. So we are running at, let's do a failover. Now why would you do failover? One is, we do provide automatic failover. Okay, so let us say this particular region goes down, it will find out which region to failover to, so which we would have given a priority to, and we'll talk about that in a bit. But let us say you want to do a DR exercise, or let us say you want to do the follow the sun exercise. Okay, how would you do that? So let's pick up, let's say, South Central US. I think it should be all right, right? Let's do that. And I understand, because this is the manual failover. Yeah? It will take, I don't think, at this point of time, a lot of other services provide that, so this will go on. So what is happening at this point? No data is lost. The application is running as it is. We are making sure that all the writes will start going to the South Central US at some point in time. Okay. Now, this should also reflect, so it will take a few minutes. As soon as it's done, we will switch over to the other side. Yeah, fine. You want to. So this will keep on going on. Let's see.
Where you choose South Central US?
Yes, I did. It's updated. Yeah. It will take a few minutes. So now the question is, when let us say there was a region failure like this, what would happen to your applications, right? We don't do. We definitely will not see. We definitely make sure that you don't fail over just because 1 or 2 requests did not go through. So we have a way to identify whether the region is completely down. DNS, outside world access, inside monitoring tools. And when we declare the region is down, at that point of time, automatic failover will happen. This is a controlled failover that we are doing at this point of time. Okay. As soon as when it is done, I think it will start coming up. We should be able to see that thing has failed over. And let's see. So that is it. South Central US should be running up and running. Yeah.
Did the world notice any blips during that failover?
No, you will not notice anything. So this is manual control, right? And when it is automatic, even then we fail over automatically. Okay. Now the question, there are a lot of questions in our mind. Okay, what is the consistency and all those things? We would be interested to discuss all that in a detailed discussion. Let him know at the back that you are interested, and then we will follow it up with deeper discussions. But this is a key part, right? Taking away the pain of managing systems.
Yeah, if you quickly notice here before it goes away,
Yeah.
when it failed over East US, latency now, write latency is now going up to like 40 because
Yes.
of the speed of light between East US and South Central should be somewhere.
Yes.
Yeah, 30 plus. And you see that South Central US, which was 60, is dropped down to 10 finish. And that's instantaneous. I mean, when that is done, it's
And I think I'll just take 1 minute of your time. One is why this DocumentDB, and we are very passionate and we will say this. End of the day, you see cars are driving themselves, trucks are driving themselves. There is no incentive for us to push people managing machines every day and day out. So let's try to take away major pains and then see what else we can do. And this is an effort towards self-healing, self-managing databases that Microsoft has been doing for a number of years. With SQL Server also we have been doing that. This is just another effort as part of that. Okay.
cool. Actually, talking about cars driving themselves and trucks driving themselves before that question, we actually have applications, not driving cars, but at least there are telematics applications for both trucks and cars by top automobile manufacturers that's actually leveraging DocumentDB where real-time cars are actually sending this information to DocumentDB. Why? Because lots of data to ingest, very fast ingestion required, scale based on the different needs, the scale keeps on changing, and then they're actually building, in one case they're actually building for a luxury automobile manufacturer is actually building is that, diagnostics information, when do you need to actually take your car to the dealership or the mechanic, all of that is done through an app that's backed by DocumentDB. We have similar applications where truck manufacturers, truck drivers, where are they, have they finished their delivery, any of this is using DocumentDB.
I was just a little confused on that previous one. How come the reads weren't affected by that speed of light latency?
Because we read from the local region.
Okay.
We always read. So what that's saying is, when you're reading from the local region, so you are always guaranteed. When you're writing to one region, and then the speed of light is what it takes to
Replicate the
replicate the data from that particular region to the other region.
All right. Thanks.
Yeah.
So the scenario I mentioned was the IoT scenario, right?
Right.
So generally in those scenarios we use event hubs.
Yes.
So we can use directly DocumentDB instead of event hubs?
Yes. So a couple of things, no, you could use Event Tab if you want. A couple of things, and a whole lot of the IoT scenarios, including the car platform that we are actually Microsoft has released, uses DocumentDB. We actually have a feature called a change feed. I actually have a slide on that. Using change feed, you could use one DocumentDB account, one for ingestion as well as for the process data running Spark on top of it.
So I was going to ask, in your example code, you have a list of preferred regions. So I take it that's only the reads? Is it the race the client doesn't know or doesn't have a choice?
Write will automatically fail over. So region 0 is the first write region, it will automatically fail over to the next one.
If you want to show, we can show it later.
No,
But yes, you are right.
I get it.
Yeah.
So,
Yeah.
is the name DocumentDB because it was made for documents?
You had to ask. Sorry. Yeah, no, so, we are creative engineers and building stuff, not creative in naming. So when, I'm actually, so when we named it, under the cover, NoSQL those days used to talk about what model they supported. Even though we are a multi-model database, we support key value stores, we support document stores, and we'll support all the other stores in the future. Some of them actively in the works, I'm not disclosing them now. Since it was being stored as a JSON document, I think our Microsoft marketing said, hey, let's call it DocumentDB, right? Something that we are actively working on.
One more. I read somewhere when I was preparing for this session that security is not as good as SQL Server. Is that correct?
So,
Specifically social security numbers and HIPAA.
I actually have a slide. DocumentDB is HIPAA compliant. We're working on SQL is already compliant with respect to a lot of other compliance. We haven't gotten all of them. It takes compliance audit, and DocumentDB has been in general availability for the last 2 years now. So we have embarked on the compliance journey. My slide will say, I think around June timeframe, we'll be actually done with the compliance. We are actively, as of tomorrow morning, we'll start rollout of encryption at rest. So encryption will be there. So I don't think there is, we actually even had a blog in terms of some of the security aspects of it, which I can actually share.
So it's only temporary, even if there is something, right?
Correct, yeah.
In future, it will all be.
Yeah, so we'll have all the Azure compliance. It's a ring zero service, as I said. When you talk about most of the cloud providers are actually looking at, including us, looking at a whole lot of our market, addressable market being in the IoT space, and IoT actually uses DocumentDB in this case, so we have to be compliant and secure. So we'll have all the Azure security, we already have, and the compliance met by within the next couple of months.
And SharePoint Online will be using this because it's obvious.
No, so this is actually kind of this is how we named it causes that. SharePoint Online is not actually using DocumentDB because the documents we're talking about here are just JSON documents, right? And SharePoint uses, the documents they store somewhere in blogs, and then they have data, the metadata that they store in a database. They don't use us for that particular metadata.
There's one more question.
Sorry, I was late, so maybe if you already answered this question, you can just skip.
Oh, yes, I did. Oh, sorry.
So, when to use SQL and when to use DocumentDB?
It's a good question. I think, let me provide the pivot point that I actually have, right? So the way I look at relational databases were actually built for scale-up. Even though they are distributed in a particular region, they were really built for scale-up. So if you have to grow your database up to terabytes of data, I think relational database provides it. But if you're really thinking about a globally distributed database that you want in all the regions for modern mobile applications, SaaS applications, IoT scenarios, and still guarantee you this low latency rights, etc., then you need, and if the data could grow up to like petabytes of data, you need databases that are purpose-built for that. DocumentDB is a database like that. Then if you go beyond petabytes of data into hexabytes of data, like almost all of our services use all three of them, where you really need a data lake where compute is separated out from the storage and you can run MapReduce or you can run streaming, batch processing, all of that, then you really need a data lake kind of thing. That's the viewpoint we have in between these three data spec.
Is there a different NoSQL, Microsoft version of NoSQL, or is this it?
This is it.
So,
No, it's Azure Table Store.
so let me actually, so Microsoft will have a continuum of NoSQL offerings. Currently, they have different brands and different things. So we have if it's a key value store that you require, you don't have some of this. I mean, go with touch base on the indexing capabilities. You don't need fast querying capabilities. You don't need server-side processing. You really need a key value where you put it and read from it. There's Azure Tables. DocumentDB is more on the look. If you really want low latency in terms of, you can still do key value like gaming applications. And we have a lot of gaming applications that use key value store semantics with us because they want that fast ingestion and as well as the low latency aspects of it. So tables, DocumentDB, and then our approach is, we don't have all of them. Our approach is we want to go where the developers are in terms of the tools and technology. So we will GA within the next few weeks our MongoDB head, which is, if you talk to Mongo, if you use the Mongo framework, just consider DocumentDB as a Mongo managed, better, secure Mongo instance, and it should work. Somebody else?
Is strong consistency ACID compliant?
Yes, yeah. So DocumentDB actually is ACID compliant, but in terms of we provide snapshot isolation.
So you have strong consistency in the region, and ACID compliance is done for multiple batch items. So you want to push through together the transactions.
Yeah. So I don't know if I have that. We do provide support for multi-document transactions. I do have it.
I think you know.
Yeah. Okay.
So no question I can answer.
Yes.
Last, the worst question. What are the downsides of this? Everything you said is great, but there's got to be a downside.
What would I say? So, I don't know if it's a downside. There are some trade-offs you sometimes make, which is it's a provision throughput system, which means you actually pay for the compute separately from the storage. It's not like, if you look at Azure Tables, it's a lot cheaper in terms of, because you're pretty much paying at a storage thing and the transactions are not expensive. Here it's a provision-based system, so it's more like, if you're building real applications, you will need something like that. What else?
I think you have very small workloads like 5 GB, 4 GB,
Yeah,
6 GB. I don't think there is a great, we are not.
Yeah, if you're really not looking at scale-out applications, then
At the beginning, it seemed like one of the problems was also if you're trying to do very complicated multi-collection joins with very complicated predicates.
yeah. So
This kind of falls down compared to.
correct. So that's another one. Like if you're looking at real complex joins that relational databases provide, one way I would actually approach it is, if it was 2017 or if it's 2016 and we were rewriting all these applications, we would really write it differently. And I think the DocumentDB wouldn't probably have a lot of downside. But that's not real world. There is a lot of real world applications that were built with specific purposes. Normalization came into being. in how we did. So I think some of those applications may not be able to directly leverage it. So if you're trying to lift and shift a whole lot of SQL or relational database applications, I don't know if it will require some re-architecture. We do have though, we are working with a large financial ISV that actually has one of our competing red-colored relational database footprint is trying to move from what they wanted to say was they wanted to move from a data store like that to what they said is polyglot database, like multiple databases. They want DocumentDB, they want SQL, they wanted Mongo, they wanted one. And we had a conversation with them, and currently they're looking at building that polyglot database using DocumentDB, just using DocumentDB.
But yeah, to address the question, you would design separately, so there is a little bit of effort moving from traditional relational systems. So that is